Howdy, IB. It's Miss Kosh. I was asked if I could work a couple of problems, make a video for you. So the first one was this number 12 on page 211. So they don't give us any size dimensions, but they do tell us that we've got this 12-sided regular dodecagon. And so what I realized here was that this would, oh, wow, that's a really big dot. Can I make that smaller? No, I just zoomed in too much. Sorry about that. Okay, so let me just use a different color for a second. What I discovered, if this is the center of that, then this would be a radius coming down, and this would be a radius coming down. The apothem would kind of come through here somehow. Okay, we'll talk about that in a second. Oh, that's too much, but all right, now I've got problems. Okay. So this is the radius goes to the center point right here. So if you'll notice, to get all the way across that coin, it's going to be 2r. Well, then there's another coin down here, so that's 2r and 2r. That means that this dimension here is 4r. Likewise, we have 2, 4, 6, 8 going this way, and so that dimension is 8r. So to find the area of the rectangle, it's just going to be the area of, well, let's not use yellow. That's silly. No, let's use blue. The area of the rectangle is going to be equal to 32r squared. Okay, and so then we need to find the area of each of these dodecagons and then figure out what the ratio is. All right, so here goes nothing. So what I'm doing off to the side, I recognized if I put in all these little radii, it's going to divide the whole 360 degrees around this. It's going to divide that by 12, okay? So there would be 12 little radii that come off, and so each one of them is this angle. Whoa, okay, I was in the wrong thing. That angle right here would be 30 degrees. And so when you drop in the apothem, this is the apothem right here, that's going to split that into 15 and 15. So what we need here, our formula is for the area of a regular polygon. We talked about this in class today. It's equal to 1/2 AP, where it's apothem times the perimeter, or you could say that that's equal to 1/2 ASN, where it's the apothem times the side length times the number of sides. Okay, so on each of these, this is the side, this is S. Let's go ahead and use this formula just because we're going to find S in relation to this R. We're going to find A in relation to R and then go from there. Okay, so where were we? I can say that cosine of 15 degrees would be equal to A over R. That tells me that my A value is equal to R cosine 15. I also know that, well, S over 2 would be this little piece right here. Oh, that's bad notation. Okay. This whole thing is S, so that little piece is S over 2. That's what so sine of 15 is equal to S over 2 divided by R. Okay, so what we need, so we have S over 2 equals R sine 15. In other words, our side length is going to be twice this little piece, obviously. And so, well, I didn't mean to sound arrogant when I said obviously, but hopefully if you're in HL Math or even SL, that would be obvious. My bad. Okay. So now I can use that formula and say that the area is equal to 1/2 the apothem we found to be R cosine 15. The side length, 1/2 R. S is 2R sine 15, and then our number of sides, there were 12. Okay, and so the area of each one of these is going to be, what is this, 12R squared cosine 15 sine 15. If anyone is watching this and they've already taken pre-cal or they already know what's going on, it might be, actually, we could kind of do this by hand. Check this out. There's a property that we're going to learn later. So if you've not seen the trig, then don't freak out. But if you have seen the trig, this pops right out at me, and I think it's kind of cool. And that is that, I I don't know why I wrote a C, that sine of 2 theta is equal to 2 sine theta cosine theta. And so if I were to have, I could say that sine of 30 degrees is equal to 2 times sine of 15 times cosine of 15. And notice that's what I see right here. So this 12, I could think of this. Let me show you everything I'm going to do. This is 12. 12 is 6 times 2. Okay. And then sine 15 cosine 15. So now, so 12, right? I have just, that's equivalent. 12 is equal to 6 times 2. This 2 sine 15 cosine 15 is equal to sine of 30 because of that property. Everybody, I'm going to teach it to you later, so hold tight. I just am too lazy to go find a calculator. So the area of each one of these is going to be 6r squared sine of 30. And now, if you think about your unit circle, sine of 30 is equal to 1/2. So the area of each one of these is 6 times r squared times 1/2, which is, the area is equal to, what is this, 3r squared. Now, that was the area of one individual coin. Well, I noticed that we have 8 coins. So the whole thing will be 8 times 3 is 24. So the area of the coin divided, the coins plural, or divided by the area of the bill, the paper, or whatever, would be equal to the area of the coins. There's 8 times 3r squared, which is 24r squared. It's, we already said that the area of that is 32r squared. The r squareds cancel. I can divide by 8, and I get 3/4. So did I answer the question they asked? What fraction of the note is not covered? Okay, so 1/4. So notice on that one, I had to go back and make sure that I answered the question they asked. I am going to try to explain this question and this question, but let me make that another video. So, all right, good luck.